Good morning to all of you. In this lecture, I am going to discuss that how to construct a Lagrangian for a physical system, that is Atwood machine. So Atwood machine, Lagrangian for Atwood machine. So what is Atwood machine? Means we will set up a Lagrangian, or we will how to construct a Lagrangian for this very important physical system, that is Atwood machine. So Atwood machine, its schematic is simply this is a pulley, a mass M1 attached. This is M2. So this physical system is known as Atwood machine. The length, distance from this mass M1 to this point is, let's say this is Y1 and this is Y2, and the length of this string. So Atwood machine is a system in which two masses M1 and M2 attached to a massless string of length L. This is just a general definition of this physical system. So we have, so physically, and we will analyze the mechanics, means mechanical parameter corresponding to this very well known physical system, that is Atwood machine. So this physical system is known as Atwood machine, and we will construct we will construct a Lagrangian corresponding to this system, because once we construct a Lagrangian, we can evaluate each and every parameters. So Lagrangian is basically, and before going to write the expression of Lagrangian, we should know the basic parameters, basic classical mechanical parameter. What is classical mechanical parameter? Means we should know equation of constraints, we should know what is the generalized coordinate, we should know what is the degree of freedom of this system, what is the potential energy of this system, what is the expression of kinetic energy of this system. So let us see. So Lagrangian, simply this is T minus V again. So what is kinetic energy? Half m qk dot square or half m v square. So this is kinetic energy. And what is potential energy? Potential energy is energy due to its position. So if the mass is here, its potential energy is simply mgy1, and this is the reference point. So minus mgy1. So this is the reference point. So what is kinetic energy? Let me write it one by one. So kinetic energy, which is T, which is half m qk dot square. So what is the coordinate of this system? Let's say this is x1, y1 and z1. This is the coordinate of this mass m1, and x2, y2, z2 coordinate corresponding to this mass m2. So x1, y1, z1. And what is the motion? What is our goal? What is the generalized coordinate? Generalized coordinate is number of independent coordinate that describe the motion of our physical system. So what is the motion? It means the motion is only along either this mass ascend or descend. Either this mass ascend or descend, depending upon the magnitude of this m1 and m2. This is the situation that we have. And in which direction? Only in this vertical. So we have only one motion, that is vertical motion. So in this Atwood machine, the Atwood machine exhibit only one vertical motion because of this situation. So this is mass m1, so it can move either this way or this way, this way, this way. So it has only one independent vertical motion. And what is the direction? Let's say this direction is y. This is our x, this is our y, and this is z. So it has only one direction. Its motion is in only in one direction. So it has only one independent motion. So it has only one generalized coordinate. So definitely it should have only one degree of freedom. So before going to the details of kinetic and potential energy, let me write the equation of constraints. And again, this is a conservative system. So what is equation of constraints and degree of freedom? Equation of constraint. So the motion is only along y direction. So y1 is, so x1 is 0 and z1 is 0. What about this mass? Similarly, x2 is 0 and z2 is 0. So we have four different equation of constraints. And we have one more hidden constraints. We have one more, that is length of this string, that is the length, this one. Length of this string, which is equal to L equal to y1 plus y2. We can consider this part also, but this is very small, that's why we can consider this part also, because this is the circumference, this is circular, pulley is circular, is in nature, so this radius is very small, so we can neglect this, otherwise it is treated as a constant, so it is not going to play any role in equation of motion, so we can neglect. So total length is simply y1 plus y2, and you can also consider the half part, because your length is in this. What is total circumference is 2 pi r, so half circumference is simply pi r, but we can neglect because this is very small. So total length is simply depend upon y1 plus y2. So we have one more equation of constraints. So total number of equations of constraints in this system is 5. In this system is 5. I have already told you, if we are able to recognize the equation of constraints, then we can predict around 80%. We are able to write the Lagrangian. Before the knowledge of constraints, if you don't know what is equation of constraint, we cannot find out degree of freedom, and we cannot construct the Lagrangian or exact expression of Lagrangian. We cannot construct the correct expression of Lagrangian. So we have one more hidden constraints, that is because this is in only one direction, motion is in only one direction, which is y direction. x1 and z1 is 0. Similarly, corresponding to mass 2, x2 and z2 is 0, and length of the string is 0. So we have, what is the value of k? K is number of equation of constraint used in the system. So which is, so value of k is 5, and what is degree of freedom? D, which is 3n minus k. So what is n? N is simply 2, because we have two masses. We have more complex situation of Atwood machine, but this is the simplest situation in which only two masses attached to a massless string of length L. But we have more complex situation. We can attach more masses in order to make a complex Atwood machine. So this is 3n minus k. So n is simply 2, because we have considered only two masses, and k is 5. So 6 minus 5 is 1. So degree of freedom is 1. So degree of freedom is 1. And this is the mathematical calculation. So mathematics is the language of physics. So we have only one degree of freedom. It means particle can have, our system have only one independent ways through that. We have only one independent way by which our system can move. So it has only one, and physically we can analyze also. This pulley, this is pulley, this is mass. So this mass has only vertical motion. It has only one direction, means it has only vertical motion, and this mathematics d equal to 1, which also tells that it has only one independent motion, which is in y direction. So now degree of freedom, equation of constraints. So this is another objective question that can be asked in your examination, that what is the degree of freedom corresponding to this Atwood machine. So you can mathematically calculate and you can physically analyze. Okay, in this physical system we have only one vertical motion, and this is the number of equation of constraints, and this is the value of k. So now equation of constraint is different thing, and number and k is the number of equation of constraints used in the system. So k is 5 and equation of constraints is this one. So it's all about. Now the Lagrangian corresponding to this system, if our x1 and z1 is 0, so what is our kinetic energy? Kinetic energy, let us write the kinetic energy corresponding to, in order to construct the Lagrangian, what we will do? We will simply write the expression of t and v separately. So what is t? We have two different types of generalized coordinates. So kinetic energy is simply half corresponding to mass m1, that is x1 dot square y1 dot square plus z1 dot square, and corresponding to mass m2 we have kinetic energy is simply x2 dot square plus y2 dot square plus z2 dot square. Now since x1 and z1 is 0, since x1 0, z1 0, which implies that their dot is also 0. z1 dot is also 0. Here x2 is 0 and z2 is 0, which implies that x2 dot is 0 and z2 dot is 0. Now putting this value in this, so our t is simply 1 by 2 m1 y1, because y1 motion is in y direction. So this is y1 square plus 1 by 2 m2 y2 dot square. This is kinetic energy. Now what is potential energy? So potential energy V is simply, what is V1? Potential energy corresponding to this mass m1. So which is minus m1g y1, and potential energy corresponding to mass m2 v2 is minus mg y2. So from this equation we have a relation between y1 and y2. That is why this is equation of constants. So y2 is simply L minus y1. So we can replace our y2 by this y1. And what is y2 dot? Y2 dot is simply minus y1 dot. This is another important equation of constant. So this is minus mg, y2 is minus y1 dot. So which is plus mg y1 dot, m2 y1. This is m2, this is m2, this is m2g. So total potential, since potential is scalar, so we can add it directly. So minus m1g y1 plus m2g y2 is L minus y1, sorry, L minus y1. This is again minus, and this is m2g L minus. So this is the total potential energy corresponding to this physical system, and this is the kinetic energy. We can convert our, because y2 dot is minus y1 dot. So what is our ultimate expression? Our final expression is simply m1 plus m2 y1 dot square, because y2 dot is minus y1. So with the help of this equation of constants we can convert our Lagrangian. So this is t and this is v. So what is our L? Simply L is t minus v. So L is T minus B, which is 1 by 2 M1 plus M2 Y1 dot square plus M1 GY1 plus M2 G L minus Y. So this is the Lagrangian corresponding to, this is the expression of Lagrangian corresponding to Atwood machine. Once we know the Lagrangian and what is the generalized coordinate, whether this is correct or not, let us check. This given expression of Lagrangian is right or wrong. So how to check? Check number of degree of freedom is equal to number of generalized coordinates. So number of generalized coordinate is y1 because motion is only along vertical direction. So number of generalized coordinate is 1 and degree of freedom is 1. So this is correct. So our Lagrangian is correct. So we can proceed further in order to find out the Lagrangian equation of motion. So this is the way to find out. In one example or in one physical system, we have so many objective and subjective questions that. So what type of question that can be asked? What is Atwood machine? What is equation of the first question? What is Atwood machine? So this is the system which have motion only along vertical direction. The simplest one is two mass attached to a mass via pulley with massless string of length L. What is the equation of constraints? So it has 5 equation of constraint because it has only one motion. It has only vertical motion in one direction. So only one independent way it can move. So and it has, what is the degree of freedom of this system? So we can calculate it mathematically and we can analyze physically also. So it has only 1 degree of freedom. What is the potential energy? What is the kinetic energy expression? What is the Lagrangian? And it's all about the, once you write the Lagrangian, it means 80% you have completed your job, 80%. Now you can write down, you can find out the Lagrangian equation of motion in order to predict its motion. Whether the mass is descending, which mass is descending, which mass is ascending. This is the physics behind this pulley system. This is the basically mass pulley system in which we can analyze, we can say that which mass is, if M1 is, what happens if M1 is greater than M2, whether it is ascending or descending. So through the equation of motion we can find out the expression. So in this way, so we have another, I just leave up to you that write down the equation of motion because it has only one generalized coordinate, so corresponding we have only one differential equation of Lagrangian equation of motion. So it's all about Atwood machine. Thank you.